So today in our 11th grade physics class, we're going to be starting a new unit on kinematics, free fall, and Newton's laws. So today we're looking at free fall. So what we have here is called a drop and shoot. And we have two options. We can either shoot a ball off one end or drop it through this hole right here. When I drop it through the hole, what it looks like is this. Alright? When I shoot the other ball off the end, we have this. Now, the question we have for the class today is if I do it at the same time, what do we think is going to happen first? Which one's going to hit the ground first? The ball that shoots off the end or the ball that drops through? Let's get a show of hands. Who thinks the ball that shoots off the end is going to land first?
By land, do you mean like hit the wall or hit the ground?
Hit the ground.
Hit the ground. It'll hit the ground and then it might bounce.
Oh, okay, cool.
Who thinks the one that drops through the hole is going to land first? About 2/3 of the class. Who thinks they'll both hit at the same time? About half, because those fractions match. All right, so we're going to go ahead and do it and see which one goes first.
Is there a prize?
There is no prize, except for knowing you were right.
Knowledge.
All right, so it's going to be a little hard for everybody to see, so you're going to have to all be really quiet and try to hear when they land first. We'll do this twice so that we can get a solid sample. What do you guys think? Same time? All right. There's some discussion here. Are we saying the same time or do we have some dissenters?
Same time. Same time. Same time.
Drop ball. How about we do it one more time and try again? All right. That one did bounce, but you'll notice it didn't go quite as far either. So, all right, here we go. One more time.
Half a second flam means nothing. That means your ears are broken.
So, what do we think it was?
Same time. Same time.
Are we saying same time?
Same time.
All right, that's the correct answer.
Okay, so now we're going to use a superficial solution. So, Elizabeth's going to put the words to the problem on the board, and I'm going to help you draw it out.
Maybe.
I'm going to explain it, so even if it's not up there, you can follow along. Okay, so we have our plate. On this plate, we have Ralph. And Ralph is going to jump off the cliff. Actually, he's going to run off the cliff. There we go. So, down here, we have Ralph's friends.
That one's on her.
And
Okay.
they're going to put a pool of some sort there to catch him when he jumps off the cliff. So, the question that we're answering is, how, if Ralph is jumping off at 2 meters per second, how far away from the cliff do Ralph's friends need to put the pool for him to land in it? So, the concept that we're getting at here, we're going to put on a coordinate plane so it's a little bit easier to think about. So, this would be y, and this is x. So, another way to think about it is this is x, and then this is y. So, Ralph is following this path, and he's going to follow the same path as the ball that flew off. The idea is, did the ball, did the distance the ball traveled in the x direction affect the time it took for it to drop? We all agreed no, right? Okay. So Elizabeth's going to help you plug the numbers into this equation to solve the problem.
Yes, I am. Right now. Perfect. So this was our problem, right? So
Faith explained the problem overall. We also have it in a word problem form that'll make you laugh, so I'm going to read anyways. Ralph, of average height and weight, decided it was a good idea to jump off a cliff. Except he's not going to jump, he's going to run, because jumping would change the physics. So we're going to make it easy. His friends are smarter than him and knew this was a bad idea. So they decided to put a pool at the bottom so that he would not turn into a pancake. Okay? So, we were able to say that, the average person runs at about 2 meters per second if they're like a jog and not a marathon runner. So Ralph is able to get a running start. He jumps off. We need to figure out where to put the pool. Awesome. So we have our, yes, math. Science involves math, unfortunately. Sorry. So we have our equations that we talked about earlier today in our lesson. And we have all of the variables that those equations involve. So from our problem, we can figure out what variables we know and what variables we don't know. Since we're still learning, I'm just going to walk step through this process to allow time for discussion at the end. So our delta x is the distance from the cliff to where the pool should be. We don't know what that is, so we are going to call that x. I'm going to get a different color. Blue. We're going to call that x. Great. Delta y is the height of the cliff. What's the height of the cliff? 100 meters. Great, so that is known. 100 meters. Gravity. We know gravity. It's 9.8 meters per second. Sorry. Squared. Okay, time in the y direction. We don't know that. Time in the x direction. We don't know that either. However, what we just learned is that the time in the y direction is going to equal the time in the x direction. Okay, because the person's going to be essentially falling straight down. So we have an equation to find the time for falling straight down. And that's how long they're going to have before they hit the ground. So if they're going an x distance, they're going to have the same amount of time to get there as they do before they hit the ground. So we have our ty and our tx, but we can show over here that our ty equals our tx, and we're just going to call those t, our time, okay? Setting our times equal, great. Okay, I'm going to get rid of that. Now we know in our brains. So what we need to do is we need to solve our equations for the unknown quantities that we are looking for. We're going to start with the y equation. Algebra. Yay! So I'm going to make this very, we're going to spell it out, and it'll go by super fast. So if any of you really don't like math, I'm sorry. So we're going to take the 2, we're going to put it over there, because we're solving for our t. That's what we want to solve for.
We're putting the 2 at the y.
Oh, no, I know.
I know.
I was just circling the 2. So we're going to take the 2, we're going to multiply both sides by 2. And the 2 here cancels out with the 2 here. We're going to do the same thing with gravity. We're going to divide both sides by gravity. Cancel out. Is this looking familiar to anybody from algebra in maybe like 8th grade? Okay. So, this looks messy, right?
Yes.
Messy. Okay. So, we are going to rewrite this. We have 2y over g equals t squared. Take the square root of everything to end up with our final equation for our t in the y direction. Awesome. Great. Now we have to do the same thing in the x direction. Luckily, our x equation only has 3 variables, so it is very simple. I'm going to get rid of this stuff. Awesome. We have this equation right here. We're simply going to move the v to the other side. We have t equals x over v. Okay? Now, we're setting these 2 equations equal to each other. Like we said, our t's are equal. So I'm going to erase this t and plug in that t. I know, it's okay if you are a little confused. Anybody lost? No? Great. So, now we need to move our v over to solve for x, which is our ultimate goal. We want to find what that distance is to make him not die. So, we're going to take out our v, and and we are going to move it to the other side. And we now have an equation that we can plug numbers into. We're not going to do this right now. That we can solve for x. And we will figure out how far away from the cliff they need to put the pool in order for Ralph to not die. Okay? Now, we solved this beforehand so that we could give you guys an answer. It's about 9.04 meters away. And he's going to fall pretty fast. So they're going to have to put the pool down really fast. So the chances of this working are very slim. So don't jump off cliffs.
Is that with the calculation of the height of the pool, since they're not having to dig the
No,
pool?
we are not thinking about anything else except for the basic physics. We took away air resistance, we took away life. We took away everything except for what is in our wonderful space right here. This is a hypothetical situation. But the answer is don't jump off of a cliff, right? So we have basically learned in our little estimate right here, our little lesson right here, that the motion in the y direction is not going to affect or be affected by the motion in the x direction. Okay, so free fall is going to happen even if you are moving in an airplane and you are jumping out of the airplane, even though you have a starting velocity in the horizontal motion, you are only gravity is going to affect your fall down.